Okay, this video is on combinations, and combinations are another way of counting how many different ways there are of doing something. So let's take a look at this example here. It says, example number 1, we want to elect 3 officers from our club of 25 people. First person elected will be the president, second person elected will be the vice president, and the third person elected will be the treasurer. How many different arrangements of officers can we have? So the first thing I notice about this problem is that it's very similar to some that we've looked at already. In other words, the first thing I notice is that the order in which we elect these officers, the order matters. And since the order matters, I know that this is a permutation. Well, I know how to count permutations. I know how to do permutations problem. Well, there's a couple of ways. I could use my box method. I want to select 3 officers from a club of 25 people. The first one I select, how many choices do I have? 25. Second one, I have 24 choices. Third one, I have 23 choices, and I could multiply those together, and that gives me my answer. I could also use the permutations function on my calculator, and I could say the number of permutations of 25 people selected 3 at a time, and either one of those will give me my number of permutations, 13,800. So this is the number of ways that I could elect 3 officers from a club of 25 people. So the thing that I want to note about this, however, is note that, let's say that I chose 3 people from my club. Let's say I chose Julie, or say that she was the one who was elected first. So Julie's the president, and Luis was elected second, so he's vice president, and say Susie was elected third, so she's the treasurer. Well, note that if I had a different order of these same 3 people, for example, say Luis was elected first, and so he then would have been the president, and let's say Susie was elected second, so she would have been vice president, and Julie was elected third, so she was the treasurer. Notice that these are 2 different arrangements of Julie and Luis and Susie. All right, so since these are different, then we would count these as 2 different arrangements. All right, Julie, Luis, and Susie, that's a different set of officers than Luis, Susie, and Julie, and it's different because the order matters. It matters who gets elected first. All right, it's a different arrangement. Well, if you take a look at example number 2, example number 2 says we want to form a 3-person committee. That is, we're not doing officers, we're just getting 3 people together to form a committee from our club of 25 people. How many committees can we form? Well, before I figure out that number, I just want to note that if I had this same group of 3 people who ended up on the committee, say Julie, Luis, and Susie, and now they're not president, vice president, and treasurer anymore, they're just, they're just people. So Julie, Luis, and Susie, well, notice that the group Luis, Susie, and Julie, this time, these 2 groups are the same. All right, since there's no officers involved, there's nobody's president or vice president or treasurer, the group of Julie, Luis, and Susie is exactly the same as the group of Luis, Susie, and Julie. In other words, for this situation here, forming a 3-person committee, the order in which we select the committee members, the order does not matter. And since the order does not matter, that means we're going to have to do our counting differently. In other words, this situation here is not a permutation. This situation is what we call a combination. And to do a combination, to count the number of combinations of 3 people from a club of 25, it happens differently. And whereas up here we use the permutations operator or the permutations function to calculate this number, here there's a combinations operator. And so we would calculate the number of combinations of 25 people, taken 3 at a time. And if we punch this into our calculator, we get the combination of 25 people taken 3 at a time would be 2,000 300. So the number of committees that we can form from a club of 25 people, number of three-person committees, would be 2,300. And this kind of illustrates the difference between permutations and combinations. When you're counting how many ways there are to arrange some number of items, the order matters. That's a permutation. And we've already talked about this. With permutations, order matters. Well, when you're counting how many ways there are to simply group some number of items, order does not matter. That is a combination. So, take a look at examples number 3 and 4 here. Number 3 says the debate club wants to elect 4 officers, president, vice president, secretary, and treasurer, from its membership of 30 people. How many different ways could the debate club elect its officers? So, since they're electing officers, then I notice that as before, when we elected officers, the order matters. In other words, the order in which these people are elected, it matters. And since order matters, I know that this is a permutation. So I would select my permutations function in my calculator, and I want the number of permutations of 30 taken 4 at a time. I've got 30 people in my club, and I want to select 4 of them. So I punch in the number of permutations of 30 taken 4 at a time, and I get 657,720. Example number 4 says, the same debate club wants to create a 4-person committee, that is, no officers, from its membership of 30 people. How many different committees are possible? Well, in this situation, order does not matter. And since order does not matter, I know I'm dealing now with a combination. So here I want the number of combinations of 30 people taken 4 at a time. And if I punch that into my calculator, then I get 27,405. Now, these are some fairly straightforward calculations of permutations and combinations. Next, we're going to take a look at how we handle problems that involve combinations with what we're going to call restrictions. So let's take a look at this next example. Example number 5. So example number 5 says the Young Republicans Club consists of 7 seniors, 9 juniors, and 5 sophomores. They want to form a planning committee, that is with no officers, to plan their spring social. The planning committee will consist of 4 members. How many different committees are possible? Well, since I'm looking at committees, which means no officers, that means the order in which I choose people does not matter. Then that means I know I'm looking at a combination. So I just want to know how many committees are possible from my Young Republicans Club. I'm looking for the number of combinations of, let's see, 7 seniors, 9 juniors, and 5 sophomores. That's 16, and 5 is 21. The number of combinations of 21 people taken 4 at a time, because it's a 4-person committee. And if I punch that into my calculator, I get 5,985. All right, part B. How many committees are possible that consist of all sophomores? So here I notice that now not only am I asked to form a committee, which I know is going to involve a combination, but I'm also told that there are going to be some restrictions on my committee. Specifically, I'm not just going to form a committee from everybody. I want to know how many committees are possible that are all sophomores. Well, this type of restriction, it actually is a type of restriction that affects the whole group that is the whole committee. And this type of restriction is actually not that complicated to deal with. Since I want to know how many committees are possible that consist of all sophomores, well, I only have 5 sophomores in my club. So if I want to know how many ways there are to create a 4-person committee using these 5 sophomores, that's just going to be a combination of, again, I want 4, but I'm going to select 4 from how many people? I'm not going to select it from all 21 people. I'm only going to select from my sophomores. So this is just going to be the combination of 5 people taken 4 at a time. And if I punch that into my calculator, I get 5. Okay, so that was an example where I had a restriction on my number of combinations, but it wasn't a very complicated restriction. Let's take a look at part C here. How many different committees could be formed if the club's president must be one of the members? All right, so here again is a restriction that's being placed on my combination, and this is a restriction that we're going to say it applies to one position on the committee. All right, so now I've got a restriction that's kind of breaking up my committee. Now I've got one part of the committee is restricted to just this one person, the club president, and then the other slots on the committee are open to everybody else. So what I'm going to do to deal with this restriction is I'm going to use my box method again. I'm going to draw one box for each member of my committee. And remember, the boxes, the number that goes in the boxes is just how many choices do I have for that particular box. Well, the number of choices that I've got for one of my slots, I'm told the club president has to be a member. That means one of the slots on my committee is restricted to one choice, the president. All right, so this box is taken care of. That's the one choice. Now, I'm going to treat all 3 of the remaining slots together because the 3 remaining slots, now I can select anybody who's left over in my club to fill these 3 slots. Well, this is now just another combination. So essentially what I have is I've got one slot here that my club president has to go in there. These 3 slots I'm going to treat together, and I want to know how many different ways can I fill these 3 slots. Well, that's just a combination. I'm going to select 3 at a time, and how many club members am I selecting from? Well, my whole club except for the president, because I know the president's already been accounted for. So instead of the 21 people in the club to choose from, I've got 20 to choose from. And then I'm going to multiply 1 times this number here and get my final answer. So the combinations of 20 people taking 3 at a time, I punch that into my calculator and I get 1,140. And so 1 times 1,140 equals 1,140. And that's how many committees I have if the president has to be a member of the committee. All right, part D. How many different committees could be formed if the committee must contain exactly 2 seniors and 2 juniors? All right, again, I've got a restriction. My restriction, again, it applies to not just one position. It actually applies to a couple of positions. But the important thing is this restriction, it kind of splits up my committee. So once again, I'm going to use my box method here, just like I did with the fundamental principle of counting. And if my committee must contain exactly 2 seniors and 2 juniors, well then that means I've got 2 slots here that are kind of committed to seniors and 2 slots here that are committed to juniors. So now I'd like to know, well, how many different ways are there that I could fill these 2 slots? Well, again, this is a combinations problem. I want to know how many different ways there are of selecting a group of 2 seniors to fill these slots. And since the order doesn't matter, this is a combinations problem. Well, I'm going to be selecting 2 at a time, 2 students at a time to fill these 2 slots. How many am I going to be selecting from? Well, since they have got to be seniors, then I've only got 7 seniors, which means that I'm going to have to select from 7 seniors. So the number of ways that I can fill these 2 slots is a combination of 7 people taken 2 at a time. The number of ways that I can fill these 2 slots, again, it's a combination because the order doesn't matter. I'm selecting 2 people to fill the slots. They have to be juniors, which means I have to select from the number of juniors I have, which is 9. So I can calculate this number, and I can calculate this number, and again, using the fundamental principle of counting, I multiply those 2 numbers together, and I get my answer. So the combination of 7 taken 2 at a time is 21. The combination of 9 taken 2 at a time is 36. I multiply those 2 numbers together, and I get 756, which is the number of different committees that I could form if my committee has to contain exactly 2 seniors and exactly 2 juniors.